Hey, I'm doing a quick video to answer a question that's come up a bunch of times, in particular in the last several days, and it just seems easier to make a video answer that you can share with people who ask. So the question is about scheduling Ethereum transactions into the future. The sort of motivating case is you have a hex stake that's ending in 5 years. You don't want to remember or think about it or risk screwing up and failing to end it. So could you schedule an end stake transaction 5 years from now? So the short answer is no. But I want people to understand why and sort of have the intuition, because this will help, I think, with a lot of questions if you're thinking about the Ethereum ecosystem. So let's start with transactions. So when you submit a transaction, you are asking the nodes online to accept some money in the form of a gas fee, to commit some changes to the database or to the blockchain on your behalf. So right there, you already are submitting your transaction to be processed in the future. Now the future is 5 minutes from now, but it's still in the future. It's not a synchronous process. You don't submit the transaction and then it commits to the database. It may never get run, and it may get run in 5 minutes. It may get run in 6 hours. It may be run in 2 days. It's not up to you. So you can't control when your changes get committed to the blockchain, because it's on the nodes to include your transaction in a block, win the race to find the correct nonce for a block hash, and then commit the changes. So this should start to give you an inkling why it would be hard to schedule in the future. There's already a scheduling problem. So if you use MetaMask and it recommends that you do like an average speed or a slow speed or a fast speed transaction, it's taking a guess at what gas price you can offer that will incentivize block producers to include your transaction sooner rather than later. Or if you do the slow option, best effort whenever you get around to it. And because the blocks aren't full, eventually your transaction is likely to make it, because what else are they going to do? They got to produce blocks, they want to collect the fees, so they're going to include you. But if you say include a little rider clause saying, I'd like you to execute this transaction, but not now. Do it later. And in fact, do it not before 5 years from now. There's very little incentive for nodes to hold on to your transaction in memory, or write it to a database, or persist it in some way so that 5 years from now, when they've switched out their hardware twice, they've upgraded their operating system, they've upgraded their ETH client, they come back to this dusty old record and say, oh, look, it's time to run the such and such transaction. Well, let's see, what did they offer as a gas price? What am I going to get paid for running this on time? Is it worth it to me? Is it even relevant if we're in like a proof of stake system where maybe gas price is not quite the same? What if we've had a lot of adoption and competitive gas prices are 20 times what they were? So there's too much that you can't know about the future nodes that may or may not run your transaction. So additionally, let's say there were a node, let's say there were a protocol where a node could commit to running your transaction at some future time. You would get a receipt. For example, there's a system called Ethereum Alarm Clock, I think, that has contracts that let you pre-sign transactions to be run in the future, and you put a bounty on that transaction, and they have nodes that just sort of scrape the pool and see what's eligible to be run. But you don't get a promise that you can actually do anything with. The same thing if this were in the base protocol for Ethereum. Even if a node said, yes, I will do this for you in 5 years, what are you going to do if they don't? I mean, this is a decentralized system, and this is sort of the crux of what the difficulty is in building cohesive decentralized systems. Nobody takes responsibility for anything. In fact, there's no way to attribute responsibility. All you have to work with are incentives and punishments. So you incentivize people to run your stuff by offering to pay them to do it. And the punishments, so this is a common scheme that's used to basically make people live up to their commitments, and that's bonding. So this is a core part of the proof of stake stuff, is that to be a producer, you have to put something at risk that will be taken from you if you don't meet your commitment. And this is a bond. So you put up 1,000 Ethereum or whatever, and it's locked and while you're producing blocks, and then there's some, whatever, unfreezing period, blah, blah, blah. There's a whole protocol around it. But the principle remains. The only levers you have are incentives and punishments. So let's say you submit a transaction through some protocol where if somebody agrees to it, they lock up some bond that they will pay essentially as a punishment or insurance if they don't do what they committed to. You still don't have a guarantee, because they may eat that punishment, or they may throttle their throughput based on what they can commit to. So they may not commit to things too far in the future because they don't want to basically exhaust their reserve. If you have 1,000 ETH that you can commit to bonds, and somebody asks you to commit to something 10 years from now, and that's going to use 10% of your reserve to commit, is that really worth it when you could just say commit to stuff in the next week or the next month and sort of cycle through, release your bond, get more throughput on collecting fees? No, that's not going to work. There's no way you're going to get some sort of long-term commitment. So to reiterate, the problems are there are very few levers to use. You can only use incentives and punishments. You can't actually trust a commitment that's going to be that it's going to be executed upon, and you have no remediation if it's not. So if your stake just gets liquidated through late fees or whatever, and you get to collect 10 ETH or whatever the bond was for the committer, that's all you get. And that's even if such a thing existed, which like in the case of Ethereum Alarm Clock, it doesn't. It's just incentive. I will pay you X to run this transaction at some future time. So you can't get any guarantee that you can rely on. You can't know enough about the future state to offer to pay enough. You can't rely on any protocol because there's nothing in the base protocol to do this. It would all be an application, and it's an application that depends on outside nodes, so off-chain resources that you can't trust. It's basically, not only does it not exist, it would be hard to imagine what sort of system could exist that could schedule into the future. Schedule, right? I mean, you could submit for 1/10 of a GUI per gas or something to create an artificial length of time. But the question is more about, can I schedule a transaction in the future? And you can't. Hopefully it's clear from the reasons I laid out why it would be infeasible to even create a system to do this. There's a lot of complexities around scheduling also. I mean, that doesn't even touch on the semantics of how you would even specify, run this not now, but at a later date, and at that later date within a certain period of time, because you don't want to start getting hit with late fees. If they're all full up and they can't get to your thing for 2 weeks, they may think, well, 2 weeks out of 10 years, who cares? But you're going to start bleeding, from late fees in the Hex context. Now, for other transactions, it may not matter. Distribute the funds in a trust fund. 2 weeks plus or minus doesn't make a difference, but it matters for your Hex stake. So, how would you specify that? How would you specify run no earlier than X and no later than Y? What would be the penalty? How would you degrade payment, if they were late for whatever reason? How would you deal with the game theory of them deciding, well, if I'm going to run it late and I'm going to eat some penalty for being late, maybe I just don't do it at all? It's complicated. So I think it's a very simple question that has strong reasons why it couldn't be done, why it couldn't be feasibly done in the system we have, or in a decentralized system at all, again, because you don't have trust. You only have incentives and punishments. The concept of scheduling a future transaction with some application-specific context, very difficult to do because you would need a very robust spec, which we don't have. So it's not as simple as just run this function at this specified time. Like you have to put boundaries on it because it's a dynamic system with nodes that come online, go offline, kind of, and we'll keep doing that. There'll be upgrades, etc. So what's a simplification? How can we simplify? Doing it with transactions is not a good idea for a lot of reasons. So what could you do instead? So at its core, what you want is, I want some fact to be true in the future, and I want to write it down. And I want to write down what I want to be true at some future date. And luckily, we have a blockchain, we have a database that you can write stuff down in. You can say, okay, so in 10 years, I want this stake to be ended. You could do the transaction now, you write some data to the database and sort of future date it. That would be a simplification. That would be something you could do. And in fact, that's what a lot of contracts do. That's something that the Hex contract does. The Hex contract writes down in the database the last things that it processed. So it makes a note of the last day that it calculated interest for, so that when someone else calls it, it can look that up and say, what is the last thing I know I did? So it can sort of pick up where it left off. So to ask about writing down 10 years in the future, I want this stake to be ended, the contract could do that, right? It could just make a note of what your commitment length was, and then notice if you're on or after that day that your stake is ended and it needs to pay you. But it doesn't want to do that. So it's literally antagonistic to the idea of automatic payments or automatic end stakes. This is, by design. Richard calls it the game theory. It's by design that the contract doesn't want you to automatically be credited for an on-time end stake. It wants the idea of late penalties to get you to come back and clean up. Could it have done it automatically? Yes. Asterisk. It could have noticed that your stake should be ended and like auto clean stuff up. However, in Hex's defense, a lot of effort went into not making you pay to run code that's going to help someone else. So if, for example, in 10 years, I end my stake and the contract could notice that there are a bunch of people in the queue that need to get paid out and it needs to remove their shares from the pool, et cetera, it could do that, but then I'm paying for it. This is a problem. So in the contracts that I've written, I try very hard, and the Hex guys did too, to not make anyone pay for anyone else's data cleanup. So the Hex contract, somewhat by necessity, somewhat by design, somewhat for business rules or game theory, whatever you want to call it, is antagonistic to the idea of automatically doing anything on your behalf. That is the double-edged sword of having global state that is cheap to update, is that you need to only make updates when necessary. And you want people to pay for the individual updates they need to make. So just to recap, there's no protocol for deferred transactions, and it would be hard to imagine how you would make one. The crux of a decentralized system is that you don't trust anybody. So you can only use the levers of incentives and punishments and build protocols around that. So there's actually no way to get a guarantee. You can only make a punishment so ridiculous that somebody is very likely to avoid that punishment. But then they'll probably never commit to the thing you ask them to commit to. The alternative to doing transaction or deferred transaction-based stuff would be to write stuff in the blockchain and just have it sort of be true in the future and sort of detected just in time. But that's application specific. And in the case of Hex, they don't want that for a variety of designs, principles that go into the code and into the business rules. So there you go. I know this has ended up kind of long and I rambled a little bit, but hopefully you have a good understanding and intuition about why this doesn't work in the general sense and why it would be very unlikely to work in most application-specific senses. And specifically for Hex, it can't be done. So there you go. Hopefully you found this useful. If you have any questions, email me, TryHex.Win@gmail.com, or leave a comment. Thanks.